Alright, are you actually going this time? Right? Alright. It took 3 hours, 2 tech dudes, my entire prep, and a whole lot of profanity, but Frank is back. Go ahead. Daily quiz. We had to reset the resolution settings on all 3 monitors. Switch it to triple screen instead of duplicating one. We needed a new HDMI extender. I had to fight with this son of... God, I hate these ancient things. Frank here is about as old as all of you. If the last 6 years of political and social turmoil are any indicator, no. Age does not mean wisdom, not even close. Yo. That is simplified fraction. Those will always give you your fraction in the most simplified form. Hello, this is different. This isn't the prism. Did Casio finally replace it? No, Casios are super good and they're menu based, so you don't have to hunt through all the buttons like on a TI. You just go to the menu, go to the app. It's been 12 years since I used one, but they're actually better than TIs. You just have to know how to use them. They're a lot more intuitive too. Remember that I want to know what you know, not your neighbor. I take that into account when I write down all you guys' daily quiz scores. Okay. Looks like we're either there or stuck. Okay, here we go. Round one, I'm going to start in point slope form. If I start in point slope form, we go with y minus y1 is m by x minus x1. And there goes. Wait a second. I don't have a slope. I only got points. So we got to take a side quest over here to say the slope is y2 minus y1, x2, x1, getting a negative 15 over a positive 18. Reduce it down, negative 5/6. Okay, now I can put stuff in there. Both points involve mid-sized numbers. Both points have negatives in them. I don't think it really matters which one you use. But I will write both, just so we're clear. I put my negative 5/6 in slope, and whichever point you use, either you put a negative 6 or you put a 9. Either you put an 11 or a negative 7 here. Meaning, in either case, since, suppose I better put both since folks are going to use either one, you either had y plus 6 is negative 5/6 x minus 11, or you had y minus 9 is negative 5/6 x plus 7. So either one of those is your point slope form. After that, to turn it into standard form, you can use either one. I'm not going to do it both times. I'm just going to roll with it as is. We'll disturb it. I'll get variables on one side, constants on the other. If I subtract 6, well, that's 36 sixths. I hate that word. Is a negative, what is that, 19? Right? 19/6? Right? 55, 36, and 5, almost 20. Yeah, okay. And then you got to take it all the way to the end zone. Might be hard to spearfish, but I'll multiply the whole thing by 6. To get standard form with integer coefficients. Okay? Along the way, did you get the correct slope? Did you put things into point slope form in the correct spots? Did you simplify into either version point slope form correctly? Did you get to standard form? Did you get integer coefficients? Okay, there's your 5 stages. Found the slope correctly, plugged things into point slope form correctly, got the correct point slope, got standard form, got integer coefficients, the different stages. Now, you go all the way back to the beginning. What happens if I miss a single negative, and that's now negative 15 over 4? The whole thing's just, right? Taco Bell after party. In that case, at the orange here, you would have the same numbers, but your slope would be wrong. But you still put it in correctly, right? You still simplified yours correctly. You'd come down here, your distribution would have a different value here. But you would still have it in standard form, wouldn't you? You would still have multiplied to get integer coefficients. So again, the process. If you can go back, and you know all this is wrong, but you can go back and point to exactly where I did it wrong. I screwed up this one thing. And then I used incorrect information correctly the rest of the way. Okay, 4 out of 5. But if there's another mistake along the way, okay, now it's 3 out of 5. And so on and so on. Okay? We do the best with the information that we have. It's when you ignore information and, facts that things get bad. So, you. The homework. Yesterday was a train wreck. Y'all thought I was bad in the morning. You should have seen it by the end of the day. Me and Frank we're going to be in counseling for a while after that one. By the end of the day, the computer didn't even recognize that the board existed. Its hardware was missing. Frank was intermittently turning off and on. Yeah, it was a problem. Nothing? 13. Let me guess. Fractions or words? Which one is it? 13. Oh, okay. So, trick. If I ever see a slope of 0, I just know it's y equals number. Because that's a horizontal line. If I ever see a slope that's undefined, that's x equals number. Because that's a vertical line. That just is those forms. Now, if I wanted to run it all the way through, I would have to start with y minus y1, so plus 2, is m by x minus 4. Now, someone came in and asked this morning, and it's a good question. Said, do I leave it like this or not? And we had said yesterday that when you're working on the problem, if having zeros in placeholders helps you to work through it, use them. But when you get to the answer, make sure that you actually simplify the answer. And in that case, well, 0 times anything is 0. So I got this. And at that point, I should recognize this is just a constant. This is y equals number. So move it over. Okay? So you can have the zeros when you're working, but not in the final answer.
My question was, which answer be correct? Because on the book it said the y plus 2 equals 0, 1. Like, would that be also
Okay. So this is the simplified version of point slope form. Look at their directions, right? And equation. So technically, both of those are right because they didn't specify the form. If you ever get a horizontal or vertical line, just good practice to always write them as y equals number and x equals number. In fact, those are probably the easiest equations you'll ever run across in terms of graphs. It's just we expect there to be more. Y'all, the number of times that I've seen a kid do you? No? There? Okay. The number of times I've seen that pop up and say, hey, graph this. And the kid will be like, well, I know it starts at 3, y-intercept. And There's no x, so if there's no x, there's like a 1 in front of it, right? So, that. Like, no, you can't just make up stuff. You can't just pretend that there's things there. Think of it in terms of a table. Okay? These, in terms of a table, input, output, if this, then what? This is like the little Ugnaught from Mandalorian. I have spoken. If x is -3, what's y? 3. Well, what if I tried 2? 3. What if I put in a 0? 3. I have spoken. And he walks away. He's done. Okay? It's a constant function. In fact, that's what they're called. Like, this is called the constant function. Just like everything else we've been doing so far are the linear functions. And then we'll review quadratics and radicals and all kinds of other stuff. Okay? No matter what, it's just 3. So if you graph all those points, it's just horizontal line. Doesn't matter what x is, because y is always 3. So, okay, I do remember someone else asking about that one too. Anything else? Meaning of life. Wow, we got like no nerds in here.
What is that?
Hitchhiker's Guide to the Galaxy. I asked the alien what's the meaning of life, and they say 42. Duh. It's the only mathematical possibility, and then they never explain why for the rest of the book. Y'all need to get geek here. First thing, I need the slope. In there goes y2, y1, x2, x1. Get common denominators. That's going to be 2/6 plus 3/6. That's going to be -4/6 minus 9/6. Right? By 3, by 3, by 2, by 2. Yeah. And then if I have 5/6 over a -13/6, dividing by fractions is easy as pie. So times a -6/13 instead. Cancel, cancel. Here's your slope. Once you got your slope, it does say to just use point slope form. You don't have to do anything else with it. So, okay, y minus y1 is m x minus x1. I just leave it ugly. Okay. After I do a bunch of distribution, after I move things around, if I wanted to put this into standard form, integer coefficients, what am I going to have to multiply by? More. Look at all the denominators. Well, 13 doesn't get rid of 2. 2 doesn't get rid of 13. So I have to do it by 26 to get rid of both. Okay. Utters. Moo. Okay. Where did we leave off? We did all the forms. I forgot to write save, so our custodian keeps getting rid of our stuff. Okay, graphify. I kind of talked about this before. You can graph by intercepts when things are in standard form. Real quick trick. Everything on the x-axis, they're all 0, y, 0, y. So if I want to know what my y-intercept is, you go and plug a 0 in for x. Anything times 0 is? Divide. So I'll have a y-intercept at 0, 3. You don't have to write anything out for that. You just get you take your big honkin' Simpsons thumb here and you cover up one of them. Okay. I was just going to do a big thumb, but looked halfway between one of the little space dudes from Among Us and a phallus, so let's just... Okay. So, just cover it up, right? If I put 0 in here, 5y is 15, 3. If I put a 0 in for y, divide, 3x equals 15, x is 5. So don't just think 5. It's 5 and I put a 0 in for y. So that's my 1, 2, 3, 4, 5 is my x-intercept. That's how you find x and y intercepts. You plug 0 in for y and x respectively. Now, y'all know if I miscounted on one of those, my line's going to be off. What can I do to make more points now? I could just plug numbers in, get a table. I heard something over there about... This is a ratio here between 2 points of a slope. So repeat that ratio. Go back 5, up 3. Back 5, up 3. 1, 2, 3, 4, 5, 1, 2, 3. Repeat that ratio. That way I don't have to do a table because we all know how much you guys like tables. Okay. So you do that and then shoot. Please use a straight edge. Some of your lines are atrocious. The straight edge tool on here requires that I have it lined up beforehand anyway, so it's kind of defeats purpose. So I'm going to have to wing it. You all, at the very least, you should have your IDs. You just got them printed off for you 2 weeks ago. Okay? If not, use a driver's license, use a library card, use a Qdoba gift card, I don't care. You got some chunk of straight plastic on hand. If you're going to do a line, make sure you do a line right. Okay. Oh, get back here. So, cover up x, cover up y, divide, divide. Those are your intercepts. Go ahead and plot them, connect the dots. But I want you to also practice that business of try to get some more points on there using that slope ratio. You doing okay, kiddo?
Yeah.
If you need to take a lap, you need anything, just get it done, okay? The power of Christ compels you. Remember, there's a big difference between watching someone do it and doing it on your own. Just because you can follow along when I'm doing it doesn't guarantee you can do it on your own. I can watch someone play guitar all I want, doesn't mean I can play it myself. I can play Guitar Hero and press all the buttons that it tells me to. Doesn't mean I can play a guitar until I actually pick it up and try it myself and practice. Same with math. Okay? Just because you can follow what I'm doing doesn't guarantee that you can do it. You got to try on your own. If I put a 0 in for x, remember that sign is still there. Divide and get a y-intercept of -2. If I put a 0 in for y, well, something minus 0 is still its something. Divide and get x-intercept of 4. I see a slope of up to right 4. I'll use it to continue some more points. Or you can chunk that up too. Yeah, that was terrible. That was really terrible. But I didn't use a straight edge. You have a straight edge. Use one. Okay. Talk to me, Goose. How we feeling? Intercepts, quick graphs. Are you okay doing it if the numbers ain't pretty?
Of course.
If you end up with some goofy fractions, Callister, shut your hole. Dude. I should not have to talk over you. Okay. I just want to make sure that everyone's got it because I'm taking the time to go through stuff that you are supposed to know before you come into the room. Okay? This year, Algebra 2 was supposed to start with like 2 or 3 days of review and then Chapter 4. That's what we're supposed to be doing. Okay? I know it's been 2.5, 3 years since some of you have seen this stuff. That's why I'm taking the time to make sure that we know it before we move ahead. Being able to write your own equation, being able to make your own graph, your own scale, is something that kids struggle with. Analysis of graphs is actually Chapter 1. The toughest part of pre-calc is Chapters 1 and 4. Analysis of graphs, and then new trig functions. Okay? And it's because we don't spend nearly enough time on this in the lower classes. Because kids say, I don't like words, and then they just quit. So, everyone's had that cricket that gets stuck in your basement or something, just neep, 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 over and over, noise the living hell out of you. And as soon as you get up to go find them, they go silent mode. Chirps per minute depends on temperature. Warmer it is, the noisier and more annoying they get. Number of chirps in 2 seconds for 2 temperatures are shown down there. 40 degrees, not going to do anything. 93 degrees, 8 chirps per 2 seconds. Think about that. 4 chirps per second. Think of how long a second is. It's going to drive you nuts. I need a graph to model the situation. Before I can do that, I should probably have some sort of equation for this. How do I even start? Okay, label things. Think about independent and dependent variable. Input, output. What depends on what? Go back to the problem. It says it right there. The chirps for the temperature. If it's this temperature, that's how noisy it is. So maybe I'll label that. I'll start with, this is my temperature. Make sure you label degrees Fahrenheit. There's a big difference. Okay. It's a guy I play with, do webcam EDH with all the time. He lives in Ontario. He says it's 35 outside and I'm melting. Around here, 35 outside, you're like, it's still shorts weather. Okay. Make sure you have the right label on there. And then chirps. Okay, now what? Well, I know that's X and Y, right? Maybe I'll just label that off to the side so I remember. Maybe I'll say X, Y is temperature chirps. Just so I remember. Okay. Well, wait a second. If temperature and chirps is X and Y, what are these? Coordinates. At 40 degrees, there's 0 chirps. What else? There you go. 93, there's 8 chirps every 2 seconds. Ooh. They said number of chirps every 2 seconds. Do we want our graph to go by chirps every 2 seconds? Right at the beginning? Okay. So let's cut those down. And let's call that 40, and 0 divided by 2 is still 0. And 8 divided by 2 is 4 chirps per second. We better write that over here, that we've changed it, that we've altered our graph here. This is chirps per second. Okay. The temperature hasn't changed. I'm saying 93 degrees. Do I want to say there's 8 chirps per 2 seconds? Well, 8 chirps per 2 seconds, you're going to end up reducing it anyway, right? So let's just get it out of the way now. If I got 2 points, what can I do with 2 points? I can plot them on the graph. I can also make an equation. Find the slope. Well, okay, maybe we should just plot the points on here beforehand so we get make sure our graph is right. What temperature scale should I be going by here? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes.
Yeah.
Do we want to go to 100 degrees? Do we want to go to 200 degrees? Do we want to 100 and
It won't become go by 20.
okay. 200's not reasonable.
It's reasonable.
Okay. I'm going to show you all a little trick. You've seen it. Whether you remember it or not is different. You ever seen in a graph, they got this little like lightning bolt break in it? They skip to a value. They're saying, yeah, I might say 0 here, but maybe I'm going to jump straight up to 100, 110, 120, 130. Instead of having the scale, I want to go by tens maybe, but I don't want to start all the way at 0. They'll have that little break to say I'm going to start here instead. Look familiar? Like, I've seen it before.
Yeah.
Probably not in a math class, more likely in your science classes. Okay. So I like going by tens, but instead of going all the way down to 0, doesn't make sense that I'm going to go to negative chirps, right? It's going to make a negative sound. It's going to do a time heist, go back in time, and it's going to take away its old chirps. Like it doesn't make sense. So instead, I'm going to have my graph do a little break, and maybe I'll start instead at 40, 50, 60, 70, 80, 90, 100, because now we can say, well, there's mid-July. There's the Washington heat bubble. Okay. I've got enough room now to get out to a feasible temperature. And it doesn't make sense for me to go past 40. The lowest amount of chirps that it ever did was 0. I don't know how high this should go. 4 chirps a second is pretty hot. I don't know. Let's go find that slope and let's make sure before we put anything else on here. I've got slope is y2 minus y1 over x2 minus x1. 4 over 53, which is awful close to 1/13th, but it doesn't reduce. I don't need to go to point slope form on this to find the rest of the equation, because what's this? Zero's in a y spot, right? It's an x-intercept. Okay, so I know for my graph here, green, I'm going to start at 0, 40, and from there I'll go up 4 over 50 friggin' 3. Doesn't make sense for this chirp scale to be going by tens, does it? Maybe I'll just go by ones. Okay. 1, 2. Because now we can go up 4 over 53, so over to 93. Connect the dots, I got my graph. Okay. To finish off the equation, maybe I'll use the coordinate that's got a 0 in it, because that's nice and easy. We'll say y minus y1 is m x minus x1. If you don't like fractions, you can give an approximation of that. But when you do, make sure that you put this is approximately. So this is the actual answer, but I can say is approximately. Okay, now go ahead and grab decimal. If you put approximately, now I can put a decimal. 4 over 53. What was that ballpark? What was that? 1/12 is so 5.183.091. So, seriously. No, he wasn't. He was getting lost. And then 160 over 53, so 3 point something. Okay. There you go. Now I can answer the question. If the temperature is 70 degrees How many times is it going to chirp in, 1 minute? What is my graph right now? Chirps per second. Okay, so take that equation you just got, plug in 70, because you know the independent variable, you know that 70 degrees is your input. Go ahead and plug 70 into your equation, find out how many times it's going to chirp per second, then do what?
Multiply it by 60.
By 60, right? If that's how many times it does it in a second, take it times 60, and you got how many times in a minute. And you'll get a number that should annoy you a lot, because crickets. I'm going to take that 4 over 53 by 70 degrees minus, right? Yeah, minus 160, what was it, 160 over. Frank is still being slow, though. 53. Doot. Oh, no. It gave me a fraction. I don't know how many times that is. I take it times 60. I don't know how many times that is. It's a big fraction. What do I do? How? I can just straight up divide the numbers. 7,200 divided by 53. Or, if we're not as familiar with these, hit math. Option number 2 is to change it to a decimal. I need to think about that. This cricket is going to chirp 136 times in a minute. Like my eye starts twitching just listening to that. Like, no thanks. Okay. So I want to write some stuff down here. Over here, I want to write some steps, some things that we should do whenever we run across a word problem. Step 1 is to label what your independent and dependent variables are. Make sure you know what your independent and dependent variables are. What matters first? What do you change? And what changes depending on that? Okay. So, you got a small office, you're going to order a bunch of paper. Based on average use, it lasts 80 days. Do you say, I have 80 days in the office, therefore I must have this much paper? Or do you say, I got this much paper, so it will last this long? Right? So the first thing you do is label this is paper, comma, days. So stage 1, you label what you're even talking about. Stage 2, do you have coordinates or do you have an equation? Everyone wrote down that stuff from the other day, right? Our different forms, like slope-intercept form is y equals rate x plus start. Okay, so you wrote all that stuff down. The office ordered 140 packs. Based on use, it will last 80 days. Do I know a starting amount? Do I know a total amount? Do I know a rate? What do I know? Do I know a data point? Do I know a coordinate? There you go. So because of that, I know that 140 packs of paper lasts 80 days. That's a coordinate. So if this many packs lasts that many days, how many days does 0 packs last? Okay. There you go. Now you can make a line. But you had to say, what the crap am I even talking about? What information do I have before that? Now that I have this, I can make a equation from either the data points or it'll actually just give us the information for an equation. Well, rise. 0 minus 80. Run. 0 minus 140 is, oh, look at that. Negative 80 over negative 140. Reduce it down. Divide both by 20. 4/7. I don't need to plug it into point slope form. I got a point right here that says 0, 0. What's the y-intercept? 0. So my equation is just 4/7 x. Now, label your graph accordingly. Make your equation. Label and graph. So X is the amount of packs of paper that I'm getting, and we got to go all the way out to at least 140. I got 10 boxes. What should I go by? 20s will fit that, right? So we'll say packs of paper. I don't have to label every single point. Maybe I say 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. You don't have to label every single one. Okay. And I know that I'm going to go out to at least 80 days. I've got 10 boxes. Go by 10s. So I'll label. This is days of use. And I can go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I can plot my 2 points. 0, 0, and 140, 80. Connect the dots. Now I can also, this whole 4/7 thing. Ooh, this was something that comes up on Smarter Balance and ACT a lot. My slope right now says 4/7. My scale is definitely not going by ones. Use your ratios that we did the other day. This is direct variation. Tell yourself if it goes 4, up 4, right 7, then maybe I ask, what if I went up 40? How far would it go over? Right? You do your Jesus fish business and you get 70. So I could say at 70, so halfway through here, 40. You can use that to make some more points. Okay? So if the slope doesn't match the scale of the graph, do a ratio real quick to make it match. And whoop, connect the dots. How many packs of printer paper should we do after 30 days? I'm just going to jam a 30 in here. What's that? 120 over 70, 70, 50, 75, 17, and a 7th? Maybe?
Sure.
Oh, you tell me. I'm guessing.
Got it.
All right, times 30, 120, 07. Oh, wait a second. Wait a second. Sullivan did a dumb. Reading the problem explains a problem. Where do I put that? Where do I put 30? Days is Y. 30 is 4/7 X.
30 days times 7/4.
Times 7/4, yes. You see where writing that label down might help us miss that mistake? That's also a really common way to write multiple choice problems for, I don't know, an ACT, where the 4/7 times 30, the incorrect answer of 17 and change, would have been one of the options. So just be careful with it. What's that? 210 over 4, 52.5. Okay. So I hope you have those written down, these little, this is how I take care of word problems. All right. I'm just going to go on from that. Either you can word or you can. Parallel and perpendicular lines. You saw them all the way back in Algebra half. You worked with them again in Algebra 2. Or Algebra 2. Geometry. You're in Algebra 2. Y'all remember doing something like this where it asked, how far apart are these lines? You pick a point on this one. Say that's 1, 5. Now go take a perpendicular line to this that goes through that point. So y minus 5 is perpendicular, negative 1/2. I swap the slope around, x minus 1. Plus 11/2. Okay, now I've got the equation of a line that is perpendicular. You did this all in geometry. I got a perpendicular line through the point. Now I go solve a system of equations to find out where it crosses here. Once I got that point, distance formula. As half the class curls into the fetal position. No, not again. Okay, so you have seen them, even if you don't like doing stuff with them. Okay, we're not going all the way down the rabbit hole. Don't worry about it. Not right now. Right now it's, do you remember what parallel and perpendicular lines even are? Parallel, same slope. Doesn't say it on there. It has it in Mathese, M1 equals M2. Maybe you want to write next to it, same slope. Same slope, never cross. Don't you do that. Oh, thought you were going to reset with a mechanical pencil. It's like, dude, skate park. Okay. Versus perpendicular.
90 degrees.
Now we know that they cross at 90 degrees. That's usually what folks remember. But do you remember how to get the perpendicular slopes? I would like you to write on here negative reciprocals. Negative reciprocals. For example, 3 is perpendicular to negative 1/3. Negative 5/2 is perpendicular to 2/5 positive. Negative reciprocals. You flip it and change a sign. Okay. Oh, also I see some scrunched eyebrows. Y'all remember parallel lines is that? Perpendicular lines is that? Literally, the symbol looks like the lines. Okay. So just making sure we remember those, because it's going to ask you those very basic questions of what's a line perpendicular to meh through meh. Well, if you don't know what parallel and perpendicular are, you're kind of hosed. But if we review it right quick like that, I'm betting we'll do okay. No. Don't you start with me, Frank, you mother. So if I'm going to be parallel to this equation, what is the only thing that I care about in that equation? Just the 6, just the slope. This doesn't matter. Okay? This is all I care about. If the slope is 6, what is parallel to 6? 6. Parallel. Parallel, same slope. So now, y minus y1 is m by x minus x1. Because you know how many kids I'll see go freshman math on this? They're like, okay, I know it's the same slope, and then coordinate, yeah, whatever. It's a y. It's the y part in the coordinate. That's very wrong. Don't do that. I mean, technically it is parallel to it, but it's not through that point. You have to remember to take it all the way. Your slope, use this point, -3 and a 1. Y plus 3 is 6 by x minus 1. It does ask for just a line, and oh, there's the directions. What form do they want it? Okay, so I do have to keep going. I'll disturb it and subtract 3. Okay. But when it asks to be parallel or perpendicular to a line, the only thing about that line that you care about is its slope, nothing else. So if I want to be perpendicular to this, what's the only thing in there that I care about? Okay. And I have to remember that -4 is perpendicular to what? Positive or negative? Okay. You flip it. 4 over 1 becomes 1 over 4. It was a negative, it becomes a positive. Okay? So now, same thing. Y minus y1 is m by x minus x1. Plug in. Slope is 1/4, 5, and 8. Keep going. Y minus 5 is 1/4, x minus 8. Distribute. And add. Okay. I would rather take the time, like Mr. Spear and I had like a 2-hour conversation before the school year started about Algebra 2 and how we wanted to handle it. What usually happens is the beginning of the year, I spend more time reviewing and front-loading. They're already at the end of Chapter 3. But as he hits hiccups along the way, they have to stop and review all this stuff. And we end up catching up to them. And I want to see if we can still do that, because we're supposed to be changing up our order a little bit this year. Okay? That's what's happened every year. We catch up to them about halfway through Chapter 5. Both! Do a parallel, do a perpendicular. Okay. I see enough scrunched eyebrows and worried expressions as we're reviewing things. Tells me we need to review it. Oh, yeah?
They just put me in algebra 2. I skipped geometry.
Oh, you're hosed. You never took geometry. Did you come from a different school district?
No. I went from algebra 1 to algebra 2.
Huh. I mean, you can. I've worked at other schools. You can do it concurrently because it's a prereq for both.
Mentioning geometry things.
Oh boy. Well, I mean, to be fair, I mentioned geometry things and everyone else just forgot them. So, yeah, go talk to Murph after this. Wander down there during Spartan time and say, look, I did the thing, I'm in the class. Do I keep going and then go back for geometry, or do I bail ship now? Boy, I haven't had one of those for a while. Okay, part A. Wait a second, what's the slope?
4x.
It ain't 4. Is that in slope-intercept form?
Oh, I told you to put it in one and then oh.
That slope is not 4.
Okay, it's 2. I knew it. I told you, Don.
Slope-intercept form has a coefficient of slope. Standard form doesn't. But y'all see right here, if I take this and I divide them, you remember we had the slope-intercept, point slope, and standard form stuff? Go back a couple of pages, and we had, where is it? Batman, there we go. Under standard form, where we wrote all that fun stuff about standard form, I would like you to write the slope is negative b over a. Because when you rearrange it, oh, I said that backwards, negative a over b. Right, because if I have ax plus by is c, move the x term over, divide by b. So either you got to remember that little trick, or you have to put it into slope-intercept form first. Yeah. Okay, so part A. This is rewritten as negative 2x plus 7 halves. So parallel now did we get it? The slope for part A is negative 2, not 4. You have to rearrange that equation so it's in slope-intercept form. Right now I don't have slope-intercept form. I have standard form. Slope-intercept form is this. Standard form is not. You can't just take the number in front of x regardless what form the equation's in. That's why we spent time moving these things around and looking at the different forms. Each one has its own uses. So I have to subtract that 4x over and then divide by 2, getting this guy. Okay, now there's the slope. Now that I got the slope, parallel to -2 is -2, same slope. Now I can go make myself an equation. Y minus y1 is m by x minus x1. y1, m, x1. Getting y plus 2 is, y'all okay if I distribute now? And then move that 2 over. Okay. Is there an argument?
He was right. He wasn't.
And you can see it. You can see the slice.
Mr. Sloman.
There is indeed. I had it right, and then he convinced me I was wrong. Because it's minus, or it's plus 8.
Okay.
And then you subtract 2.
If you really know what you're doing, perpendicular to this. What's perpendicular in 2/3? Y'all, what is this?
Y-intercept.
It's a y-intercept, 0, 6.
I did the wrong one.
You don't have to do the full form of this using point slope. -3/2 x plus 6. Because y minus 6 is -3/2 x minus 0. When you distribute, it's just -3/2 x. Add 6. Okay? So if you see little shortcuts like that, go for them. That sounds like we need practice. Both. 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 What's that meme from? It's like something with an emperor and a llama. Yeah.
Like he's in Mr. Midas algebra class.
That's not.
Well, he said he's in my I don't know if he's
Me, Spear, and Work and McCreary have Algebra 2 this year. Also, NIDA doesn't teach math.
Well, I don't know who's the math teacher.
There's also Keeler and Jameson.
I don't know who's not.
Oh.
But he's an algebra too. Like we both see.
Yeah, I shouldn't have done that.
Like I didn't know. Like they didn't give me a geometry. They just automatically went to algebra.
Well, then you signed up for it.
But that's because
Who do you have for Spartan time? I'm gonna go have a talk with her. I'm gonna give her so much crap.
Well, even like Jameson said that we would go straight to algebra 2. He never said we went to geometry.
No. Traditional pathway is Algebra 1, Geometry, Algebra 2. Now, you can go Algebra 1 to 2. I've done that in other schools, but not here. Here, someone didn't tell you the right thing.
I don't know.
The holes in her give a damn might not have been as big as mine last year, but they're still fairly big. Go talk to Murph during spurting time. It depends whether you're comfortable with what we're doing or not. Yeah. Yep.
Yeah, I'm on the next step. Why do you those are ways probably work. That's what I'm guessing we're gonna do in different ways. So there is no mistake though.
So like these two solars.
Yo!
The one says parallel. Do we get a brownie points?
Ah, I just assumed that it was going to be perpendicular. I should have crossed it out and made you do perpendicular. Yeah. Yeah. That's on me. I wasn't reading. I assumed. That's on me. What?
Is that just the answer without
Oh, no. I haven't got to the equation yet. I'm just writing the slope.
Okay. Wow. The line that's parallel and watch. It's parallel. Okay. Let's just let it. Yeah, it's parallel, but it doesn't go through those lines. Does it go through those points? Are you sure?
Plug your points in.
This guy, I don't know what he's on.
Plug your points in. Don't have your shirt covering the board. No, Monday.
next Monday on Monday?
5 days, review quiz. 5 days, review quiz.
Not 4 days, but it's 5 days.
Oh, what time?
It takes more. It takes 6 days cycle, not 4 days. Or not 5 days.
Yeah. Plug in your slopes.
Oh, wait.
Plug in your slope.
No, it's positive.
No, it's positive.
Oh.
I got it positive, but it's a -2 over -.
Did you remember that negative? Because it'll be a -2 divided by a -3.
That's the equation, yeah. I very much like it. Oh, I meant.
You didn't bring a quarter.
Okay.
I very much.
I did it right. I did it right. I just forgot.
And then you do negative. Yeah, which is
Too many people in two different places. So, lock it in. Come up here with it. Stage 1. Identify the slope. If I'm parallel to that slope, it doesn't change. Plug it in. Take your points. Plug them in. Minus a -1 is positive. Distribute 2/5, 2/5. When I subtract 1, I'm subtracting 5/5. Contestant 2. First, move your -2x over. Divide everything by a -3. The only thing in there you care about, again, is the slope. Parallel to 2/3 is still 2/3. Plug it in. Take your points. Plug them in. Y minus 10. When I distribute, remember that minus a negative is plus. So plus 14/3. When I add 10/3 to the other side, that's 30/3. Common denominators. 30/3 and 14/3 is 44/3. Okay. It sounds like we got the process. We got to slow down on the arithmetic. Okay. And maybe like me, you need to actually read the problem instead of assuming since you did a parallel, there's going to be a perpendicular. Okay. Oh, that is the last one there. All right. Not really. We were supposed to get through part of 2.5. We were supposed to go into 2.5 today.
2.7. It says 2.7 today. 2.7. 2.6.
Oh, did I swap the order in these notes? Or did I just miss stuff entirely? Are you guys missing whole sections of notes? Yeah, you are. You're missing 2.5 and 2.6. Huh. So I need to get those to you for tomorrow. Well, then it's a good thing that we end there because you don't even have the notes that we need. When you come tomorrow, y'all, calculator mojo. Does anyone know or remember? Does anyone in here know how to input data into a calculator? Okay. So if you never did linear regression back in Algebra 1 on a calculator, which I don't think any of our teachers here did, that means tomorrow is going to be brand new calculator stuff, but you're going to use it no less than 5 different lessons throughout the semester. Okay? So tomorrow's calculator mojo time, you need at the minimum a regression-based scientific calculator. So like these, I know that TIs, I know TI 34s and 36X Pros, these will do the regression stuff we're doing tomorrow. I know the iPhone free app for the graphing calculator will do linear regression. It won't do the other kinds. But the bumblebees that we got back there will do everything that we need to do. Okay? Nope. That's a big no. The Casios. Okay. The Casios will do it, but they won't do anything that I'm going to do up here. It'll do it in your own way. You got to figure out how to go through your own menus. Okay? So tomorrow is all about that calculatron. You ever do regression on there before?